All right, so we're going to finish off the 5.8 lesson. And this is the one problem that we left off on. And it says, carry out each student's strategy as described below, then draw a diagram showing the shape and dimensions of the triangle that Jamal's father should construct. Provide measurements as an appropriate level of accuracy for the given information. So here's the context, right? They're helping their father build a construction project. He needs to build a triangular frame that he's going to use in the whole project, but he hasn't been given all the information to cut and assemble a frame. He's having a hard time envisioning the shape of the triangle from the information he's given. He's given this information. So they want to find the two ways. So Jamal's approach is going to be using the law of sines. Jabari's approach is going to be using the law of cosines. And so based on that, you'll see something happens that is pretty neat. So with that being said, let me grab this one little quick page that I need help with. Okay, so the very first thing that I'm going to do is I'm just going to write the law of sines for Jamal's approach. So that, and I don't know if I've ever told you this, but you can put either the angles on the top or the angles on the bottom. It really doesn't matter. For some reason, I always tend to put the signs on top. So I go sine of A over A equals sine of B over B equals to sine C over C. And I just need a little bit of a sketch just so I can like play with this. And it's not going to be to scale at all. It's not going to be to scale at all. Okay. So I'm just going to go A here, B here, C here. Remember, A is always going to be across from A. So that's going to be 10 meters. B is across from B. So that's 15 meters. And then C is across from C, but notice you have no information. So I'll just write C here. So clearly here, my helper is going to be this guy, right? My helper is going to be this guy with sine A over A. So that's going to be sine of 40 degrees over 10 meters equals to the sine of B, which I don't know what B is, but I do know little b, which is 15 meters. So then I'm going to solve this for, and I'm just going to let this catch up a little bit. I'm going to solve this for B, big B, because that's going to help me do this. So give me a second while I let this catch up. Okay. So I'm going to solve this. So the first thing that I do is I just multiply both sides by 15 meters. And then I have 15 sine 40 degrees divided by 10 equals to sine of B. And at this point, you should be comfortable with the question that I'm about to ask you. I would ask you, how do you get B out of sine? How do you get B out of sine? I'm just going to scoot them over. That should be your hint. Yes, you would take the inverse of both sides. So I'm just going to go sine inverse here. Sine inverse here. And this is exactly how you should plug it in. So it looks like this on your calculator. So I'm just looking for my calculator. Where did I put you? Here you are. So I'm going to plug this whole thing into the calculator. Here, I'll go right here. So I can plug that into the calculator. So it'll look like this, sine to the negative first, which is how we say sine inverse. And we'll put a big parentheses and we'll put 15 sine 40 divided by 10. And I haven't checked to see if my calculator is in degree mode. So good thing I did, because now that's the correct answer. So it's 74.62 meters. Okay. So it's an angle, 74.62 degrees. So I'm going to put that up there, 74.62 degrees. And notice that looks wrong, right? Like my triangle is completely off. Like this looks like an obtuse angle. Ms. Johnson, this is 74.62 degrees. I don't really care about how the triangle looks. Now I can adjust my triangle to make sure that that's right. And then the way I'd find angle C, how would I find angle C? How would I find C? Yeah, I'm just going to subtract from 180. Very good. So 180 minus 40 minus, what is that? 74.62. So 65.38. I said 65 and I wrote 75. 65.38 degrees is my answer. 65.38 degrees is my angle C. That's what we just did. Then it says find the measure of side C using the law of sines. So now I'm going to come back into here, right? I'm going to come back over here and use the law of sines again. I'm going to use the information they gave me. That's always my preference, because I don't ever want to be wrong based on my wrong, like get another thing wrong based on my wrong calculations. So I'm going to go with sine of 40 divided by 10 equals to sine of C, which in this case, C is 65.38 degrees divided by little c. And then so I'm just going to solve that equation just the same way. The first thing that I notice is that C is on the bottom, and I don't like that. I don't like C being on the bottom. So I'm going to push him up to the top by making them do a handstand. So when I rewrite this, see if this makes sense to you. I rewrite it as 10 over sine 40 equals to C over sine of 65.38 degrees. So I just make this thing do a handstand. Hopefully it shows up pretty soon. There it goes. And now that C is on the top, I just put the bottom on the top and the top on the bottom. That's a legit equation. No worries. You're fine. Okay, so I'm going to solve this equation as soon as this guy shows up by multiplying both sides to get rid of what C is being divided by. But it's really slow, so I'm going to try to be patient here. To practice our patience. Give me a second. So as you can see in this kind of bluish color, the proportion did a handstand. So the bottom is now the top and the top is bottom. And then to get rid of dividing by 65.38, we multiply. So here's what I'm going to plug into my calculator. C is approximately, right? So I'm going to plug that into my calculator, see what I get. So I should have 10. I like to put my coefficients in front. So 10 sine 65.38 divided by, very good. It divided the whole thing. Sine of 40, again, checking to make sure that I'm in degree mode, which I knew I was already in. So the length is 14.14 meters. So this is 14.14 meters. So I'm going to take that over here. Okay. So there you go. You get that as your answer. Okay. So any questions for my little triangle so far? So these are your correct answer. This is what the triangle is correctly going to be. And then I just checked to see if this makes sense. Does 40 is across the 10? That's the smallest side. The medium angle is across the medium side, and the largest angle is across the largest side. I'm pretty good on that. So then it says draw the triangle. So now I'm going to draw this triangle with a little bit more accuracy. So I'm going to draw this triangle, except for here, you're going to notice that I'm going to pull this side in just a bit. So maybe it looks like that. I don't know. It's got to be shorter there, I guess. I don't know. Let me fix this side. You can't see what I'm drawing because I'm drawing it down here. So this is what I think it should be. So then I'm going to make this a little bit smaller so you can see both triangles. So notice here, this is still angle A, B, and C. This is 10 meters, 15 meters, and 14.4 meters. This is 40 degrees. This is 74.62 degrees. And this is 65.38 degrees. So here's what the triangle kind of looks like, right? It's not going to be perfect, but that's okay. Excuse me. So the next one says Jabari's approach is to solve for C using the law of cosines. So now we want to use the law of cosines. So I'm going to move this guy. Can I grab him? Yeah, I'm going to move this guy just over here. So there's my picture. And so now we want to use the law of cosines. And then here's your law of cosines right here. So I'll move him up here. It says Jabari's approach is solve for C using the law of cosines. So solve for C, that means I'm going to be using this one for the law of cosines. So I am going to have to draw my original triangle again, just so I can grab all that information. Let me see. I'm going to just pull this one in. Maybe I can pull this one. I'll pull this one, but then I'll erase all of my information because we're using Jabari's and not Jamal's. So I'm going to erase all the information that we found so we can just use our picture here. So this 15 meters should have stayed, and I have to erase this guy right here. There you go. All right, so I erased everything, and then so now I'm going to use this law of cosines. So law of cosines says C squared equals to A squared, which in this case is 10 squared, plus B squared, which is 15 squared, minus 2 times 10 times 15 cosine of C. Yikes. But I don't know C. So I should have used A. What was I thinking, y'all? Yeah, I don't know what I was thinking. All right, sorry. They said to solve for C by using the law of cosines. So first I need to actually use this one. Oh, what was I thinking? I'm not using big C. I'm not looking for big C. Sorry. I am now here. All right, let's try this again. So we got A squared equals to B squared plus C squared minus 2BC cosine of A. All right, here I am. I'm here now. So 10 squared equals to 15 squared plus C squared minus 2 times 15 times C cosine of 40 degrees. All right, there. That's much better. All right. Get this guy caught up. So I don't know if you saw me, but I did it wrong because, and I would love to say, yes, I did it on purpose. I actually didn't. I was, for some reason, my brain was into finding C, like big C, which means I have to use this, but I was actually looking for little c. So then I have this whole equation, which looks a little bit crazy because I have c's everywhere. I have cosines everywhere. So I'm just going to clean this up. I'm going to use Desmos as well. So I'm going to put that in front. Where did my Desmos go? Where are you? I don't know where it went. All right, so I'm just going to grab another Desmos because I don't know where it went. Okay, let me simplify while that's loading up. So I get, so right now, if you notice this problem, I just turned it into a, thank you. I just turned that into a integrated 2 problem or last year's problem because I am no longer depending on my knowledge of an integrated 3 student. So there goes that. So this is 30, and then I need to know what cosine 40 is. So I actually want to calculate 2 times 15 times the cosine of 40 degrees. Make sure that this is in degrees. Otherwise, there you go. So it's 22.98. So this whole thing is 22.98 C's. Okay. So now if you look, we have a quadratic. So we have a c squared here, and then we have a c. So I'm going to get one side equal to 0. So 0 equals to c squared minus 22.98c minus 100, right? So you can use a bunch of different methods to solve for this. You can use factoring, you can use the quadratic formula, you can complete the square. I'm going to graph it because that's my favorite way. So I'm going to graph this thing. I'm going to say x squared minus 22.98x minus 100. So you're like, Ms. Johnson, there's only one side, and then you zoom out a bunch, and you're like, oh, there's the two answers. So we have two answers, right? We have c equals to negative 3.742, and then we have c equals to 26.722, right? Did I? Hold on a second. Okay, I just figured out that I subtracted wrong. This should have been 125. So I'm going to fix that really quick and then fix my answer. Because I was about to throw out this answer because this answer doesn't make sense, right? To have a negative length side doesn't make sense. But as I do this and actually put the correct subtraction, right? So let me see. X squared minus 23x plus 125. This is also a plus because I don't know how to add again. Apologize. So then we have these two answers. We have this one and we have this one. So wait, Miss Johnson, how come you have two different sides that actually could be the truth? So I'm going to put C is approximately 8.8 or 14.14. Now notice 14.14 is what his brother also got, right? And then I have this other answer. So wait, why do I have two answers, Miss Johnson? Look at the pieces that you're given, okay? So I want to pretend that I gave you these pieces. Where's my little guy to scoot them over? So I give you these three pieces. I give you an angle. I give you a side. I give you another angle. Now, can you imagine? I can't draw this for you. I wish I could. But can you imagine that this... I wish I could draw it for you. Hold on. Let me see if I can draw this thing for you. Okay, I figured out a way to show you this. So what I'm going to do is I'm going to construct a bunch of stuff. Ignore this. This is from another class. I just wanted to use this slide to construct it. So the first thing that I'm going to do is I'm going to pretend that this is 5 units instead of 1 unit, just so I can get the 15 units and the 10 units, okay? So I'm also going to create an angle that's 40 degrees, so I'm going to do that as well. So let me just do that. And I want to make that number, I don't know if you can see this little number right here, 40 degrees. So I'm going to go like that. So it's 40 degrees. I'm going to make a segment, maybe a line that goes through there. So here, through here, just so that you have the line. Okay, so if you look, this guy is now labeled my A, and then I want to make, I'm going to pretend that this is 1 unit, and I'm going to go pretend that this is 5, and then I'll go 10, 15. And so the way that I do that is I use a compass tool. But first I need to do this. Don't worry about all this construction stuff. This is just me trying to prove it to you really clean. So this is 1 unit, 2 units, and then I'm going to do it again for 3 units. Does everybody see from here to here, it's 15 units. I'm going to say that this is 15 units this way. So I'll just label it here. And I'm trying to be as accurate as possible because I want you all to see why we came up with 2 answers. Okay. The next thing I want to do is I want to make a 10 unit. So what we're trying to do is we're trying to recreate this triangle. So I have this being 15, check, right? You guys all see my 15 units here. Oops. I don't want to do that. Sorry. My 15 units here, 5, 10, 15. And I'm going to go 10 units towards this segment, right? So the way I do that is I copy this length yet again. Actually, I could just copy 10 units. So what I'll do is I will make a segment from here to here. This would measure 10 units, right? In case you don't see what I'm talking about. This red segment here. Oh, where'd it go red? Oh, that's not what I wanted red. Oh, that's not what I wanted red at all. Oh, that's interesting. Let's see. I'll just do it. So what I really want to do is I want to make a length that's that long. So I'm going to go from here to here, and I'm going to grab my compass tool and grab that. So now, do you see how the radius is that? Okay. I'm click. So I'm going to click at the end point right here, and if you kind of notice here, I'm going to kind of put this in black so you guys all see them. This black circle, how many times does it intersect this side here? How many times does it intersect that blue line? So you'll see there's two of them, one here and one here. So I will draw both of them in. One here and one here. And so the reason why that's important is you'll have two triangles. So here's one triangle, right? And actually here's the other one. Wait, I need to change color, sorry. Cancel. I'm going to make this guy, I don't know, orange or something. But there's also another triangle right here. You guys all see this one? Right there to right here. So you see the blue triangle, which goes all the way through here, and the orange triangle that goes through there. So that's why we had two answers, right? And that's why we had two answers. So if you look, and maybe I just take a snapshot of this thing of why there's two triangles. I lost it. There it is. So that's kind of proof. There's my two triangles. And I can write all over them once I get over here. So here's my two triangles, if you can kind of see them, right? The orange one and then the blue one, right? So one of these lengths, if you look here, this is why we got 8.8. So this is the 8.8 segment here. And this one over here, this bigger segment here, is our 14.4. Oh, sorry, 14.14. So don't worry how I constructed this. I just wanted you to be able to see that with the side, this was 15 here. So this was my 15. This is 10. And there's my 40-degree angle. With my side and this angle, I actually come up with two different cases. This is called the ambiguous case. So let's go back over here really quick. It says, draw both possible triangles and find the two missing angles for each of them using the law of sines. And then we're pretty much done. So again, Jabari's surprised that this approach leads to a quadratic equation, and then he solves it and he gets two solutions. Give me 1 second. So then continuing, like, right, we have these two triangles. Does everybody see my two triangles? I know it looks messy because we have an arc and an arc and an arc. Does everybody see my two triangles here? Okay, so with these two triangles, like I now want to peel them apart so I can find the angles, because that's what they asked us to do. Now that we know all the sides, can you use law of sines to find the angles? And that's not, too difficult. So I'm just going to do that. Let's see, up here maybe. So we say sine of A, which is 40 degrees over 10, equals to sine of B. This down here is B. I didn't label anything. This is C. This is A, right? Sine of B, which I want to know over 8.8. And I'll start with that one first, right? And then so I'd solve that, and I'm just going to plug into the calculator. I think you guys are comfortable with me like looking at this and being able to solve it. So that's going to be 8 sine 10, 8 sine 40 divided by 10, right? And then that's going to be inside here, right? Sine inverse. You all should be comfortable with that. If not, not a big deal. I am going to check to make sure that I am in degrees. Yes. So this angle in here, the small little guy that matches up with 8.8, that's 30.9 degrees, right? 30.9 degrees. Okay. So then, according to that, I would be able to find out this other angle by subtracting 180. So 180 minus 40 minus 30.9 is 109 point, 100, what? 109.1. Okay. So then you would do the same thing to find the bigger angle, this bigger angle in here, by just switching out instead of using 8.8, but now we're going to use 14.14. So I will write that out in pink maybe, so it'll stand out a little bit more. So I go sine of 40 over 10 equals to sine of b over 14.14. I'm going to cheat, y'all. I'm going to cheat. Instead of putting 8.8 here, I'm going to put 14.14, and see, I get my angle as 65.35. So this guy over here, this angle is 65.35 degrees. And then I would do the same thing over here. 65.35. And so I get 74.65. Which is not a surprise because that's what my brother got, right? That's what Jamal got. So not new information here. The only new information here was the shocker, right? And it shocked Jabari too. He's like, wait a second, I got 2 answers? How did I get 2 answers over here, right? Okay, so the ambiguous case in Law of Cosines goes like this. Whenever they give you angle, side, side. So let's write that out. This is going to be funny. You're going to laugh at Miss Johnson. So angle, side, side. Yes, that's a bad word, ASS. If you remember back when you were proving triangles congruent, it never worked. It didn't work. And here's why it didn't work, right? Because it technically gives you 2 sets of triangles. Sorry, not 2 sets of triangles, but 2 different triangles, right? So ASS does not work. So in this case, it's going to give you the ambiguous case. So ASS leads you to the ambiguous case, which means you have 2 triangles, right? So basically, Jamal and Jabari need to go back to dad and say, hey, dad, by the way, which triangle did you want us to use? Did you want us to use this one over here? Right? Did you want us to use this one over here? Or did you want us to use this one over here? Right? Notice here that your law of sines, Jamal, never found that second triangle. And the reason why he doesn't find it is because there's no place for you to pop out 2 different answers. Do you see here in the squared area? You're going to pop out 2 answers. That doesn't work for here because there's no place for you to pop out 2 answers. So when you're using the law of sines, you need to check to make sure you're not using the bad word, ASS, right? Angle, side, angle looks like this. Angle, side, side looks like this. Angle, then side, then side. So basically, it's 2 sides in an angle that's not included. Okay, so this is called your ambiguous case. This is how it actually looks. The way I view this is actually using this circle, right? So if I took this length right here and I swung it, how many times did it hit this, this line right here? And it's actually twice, right? It hits it once here for a length of 8.8, and another length here for a length of 14.14. So that's your ambiguous case. This is kind of like my little drawing. Kind of proud of it because I wanted to show you without me messing it up with my great drawing skills. So hopefully that gives you a little bit more clarity on that.